The Great Barrier Reef, located off the east coast of Australia, is the world's largest coral reef system, composed of around 3,000 individual reefs and 900 islands covering an area roughly the size of Italy. Being one of the 7 natural wonders of the world, it is one of the most biodiverse ecosystems on the planet, supporting a myriad of species. It's estimated that the Great Barrier Reef formed around 500,000 years ago. However, sadly in recent years, its survival is threatened as it has fallen victim to climate change.
New findings show climate change is robbing the reef of its color.
Climate change threatens the very survival of the Great Barrier Reef. Climate change manifests as heat waves that cause coral bleaching, ocean acidification that stops the skeletons from growing, and extreme weather events, so storms that can obliterate whole reefs.
Despite their plant-like appearance, corals are closely related to jellyfish and made up of tiny animals called polyps. These small, soft polyps live in colonies, and some will secrete calcium carbonate skeletons to protect their delicate bodies. The vibrant colours of some corals are actually microscopic algae called zooxanthellae growing in the polyp's tissue. The algae help the coral by providing food from photosynthesis. In return, the coral provides algae with a safe home and the nutrients it needs. When the sea temperature is too high, corals expel the algae, causing them to lose their colour and turn white, a process called bleaching. Bleached corals are not dead, but they are at higher risk of starvation and disease. If the temperatures remain too high, the coral won't let the algae back into its tissues and it will die. Rising ocean temperatures caused by climate change are a major threat to the future survival of the Great Barrier Reef. Back-to-back mass bleaching events in 2016 and 2017 wiped out half of the shallow corals on the Great Barrier Reef. Scientists fear the 2024 event could be the most widespread and damaging bleaching event to date. Another threat to corals is ocean acidification. Around 25% of human carbon dioxide emissions enter the ocean. Seawater is naturally alkaline, but as carbon dioxide is absorbed from the atmosphere, it reacts with water to form an acid, making the sea more acidic. This makes it harder for corals to build their calcium carbonate skeletons, weakening their structure and increasing the chance of death. The rising carbon dioxide levels in the atmosphere could have devastating consequences. Severe weather events like tropical cyclones cause extensive damage to coral reefs by creating powerful waves that can tear corals apart. With climate change increasing the frequency and intensity of these storms, reefs struggle to recover before being hit again. But what is being done to help? Although deemed the best managed reef in the world, research has shown that 80% has been severely damaged since 2016. However, an exciting novel technique may be key in restoring our damaged reef. Corals reproduce through spawning, releasing eggs and sperm into the ocean for fertilization. In bleach-damaged areas, coral IVF can significantly boost reproductive rates and hasten the natural selection of heat-resistant corals. The pioneer, Professor Peter Harrison, teaches others to use a cone-shaped net, the coral condom, to collect these sperm and eggs. Lab fertilization and subsequent nursery pool growth then prepare the new corals for ocean release. But how do they get the corals to settle in damaged areas? This step required the input of bioacoustics expert Professor Steve Simpson.
To try and accelerate recovery on a reef, we're now collecting coral eggs by the million that we grow to the point that they're ready to cement onto the reef. Now, a dead reef is silent, so they're never going to find that as a place to make their home. With loudspeakers, we can play the recordings of healthy reefs and cool those coral larvae down to recruit into the degraded reef and start to bring it back to life.
However, it's important to remember that coral IVF can only buffer the damaging effects of climate change, and we must continue to fight as a planet, as nations, and as individuals to limit the intensification of these effects.
By tackling climate change and accelerating recovery, we can give reefs a chance of surviving the 21st century. And if we can save reefs, we can save anything.